Hi, it's Jan Beta, and I'm going to do another episode about the BMC64 emulator that runs on a Raspberry Pi today, because I made some adjustments and found out some quality of life improvements, and I wanted to share them with you. So here we go. If you haven't seen the previous video about the BMC64 setup, you probably want to click that right now. I'm going to put a link in the video description. It doesn't make much sense to go through the whole setup process again, because I already did that in that video. So today is just refinements and some hacks that I found. First of all, I got sound now because I ordered a proper cable right away and it arrived in the meantime. And sound output is actually pretty good. It uses the same resit emulation that Desktop Vice uses, and that's pretty good, pretty decent. You can switch between different SID models. You can also set up dual SIDs in the emulator, and you can have a pseudo stereo effect even, by setting up two different SID models and having them respond to the same address that the first SID sits at. That's pretty nifty and it sounds pretty amazing, but I only have mono in my particular setup, so I'm just staying with one single SID, and that sounds decent. You can of course choose between the 8580 SID and the 6581. 8580 sounds a bit more accurate to the original, to my ears at least. I'm not sure. Probably the 6581 with all its flaws is a bit more difficult to emulate. I'm going to jump in and show you some of the improvements I made over this week of using this basically daily. Every evening I sat down and played a few C64 games, which was pretty fun. So the first adjustment, if you will, is using a wireless keyboard. This is one of Logitech's cheaper ones. Uses a little wireless dongle, USB dongle that you just stick in the Pi, and this is powered by batteries and has a little trackpad, which amazingly also works as a 1351 Commodore 64 mouse if you set it up like that. Yeah, that's pretty fun, but I haven't really used that much because not much software for the C64 that is games software supports that. But still nice to have, I guess. The keyboard layout is German in my case, so some of the keys are in weird positions. The escape key is run stop. In my case, the control key, or in German Steuerung, is the Commodore key. And unfortunately, this has a function key to activate the function keys. So I always have to use this to access the menu. That's F12. Now I'm in the menu in BMC64. Let me take a couple of seconds to thank the sponsor for this video, PCBWay, where you can actually order some of the PCBs that fit the BMC64 as well. They can also do CNC machining, 3D printing, sheet metal fabrication, injection molding. They can populate your boards for you. They have a new service that helps you design your boards in the first place. So I highly recommend checking out the link in the video description in case you're interested in such things. Back to our BMC64. And that's probably a good place to show you some of the other adjustments I made. First thing is I'm now running this mode, which is the accurate timing for an actual C64 PAL, which works fine on my CRT that I have this connected to. Doesn't play well with HDMI screens. So there is kind of in the machine menu there you can choose the machines, which I haven't installed yet. That's one of the plans for today. But also the C64 modes. And usually you would run PAL composite at 50 Hz, which is not the accurate real-life frequency that real PAL C64 runs at, because that runs at 50.125 Hz. And there's also a mode for that. It's labeled as HDMI, but it also outputs a composite picture, which you're seeing at the moment. This is running through my upscaler. Yeah, and that works really well with my real-life CRT actually, and is the exact accurate speed. I don't really notice a difference between 50.125 Hz and the 50 Hz of the regular, more compatible modes here. So that's not a big deal, I guess, but I wanted this to be exactly the same timing as a real C64, so I set it up to this mode and it works fine in my setup. Your mileage may vary. Another improvement I did was to put a lot of stuff on the internal SD card. So I have all my games in here that I regularly play and just can set them up as drive images or cartridge images or tape images. And another nifty thing that I did was to enable the drive sounds. Oh, that's where you can set up the dual SID. If you set up the second SID to D400, I think is the address, you have a pseudo stereo mode, as I mentioned. In the prefs, you can actually activate drive sound emulation, which I did, and it's pretty cool to have some feedback about whether the drive is accessing something or not, and it sounds pretty accurate. That's pretty cool. It feels like having a 1541 drive by your side, but it's not getting as warm. And you can have a status bar that also has drive LED simulation and things like that. I also set up some keyboard shortcuts, which you can set up in keyboard. I have the Commodore key and F1 mapped to a hard reset, which is pretty handy. And I have the Commodore and F3 set to swap ports, so I can swap the joystick ports. I only have one joystick connector on here, as we've seen in the previous video. And some games, of course, on the C64 require different joystick ports in single player mode, so you can just assign this to a hotkey. And you have other things here. You can have a freeze function and yeah, soft reset flush disks. And you can have the menu, but that's already assigned to F12 normally if you have such a keyboard. If you have a real C64 keyboard, then this is going to be even more handy than in my case here with a USB modern keyboard. And then there's the main thing, because the drive emulation in the regular true emulation mode, which is pretty good for compatibility, it is pretty slow. It's as slow as a real 1541, which legendarily is very, very slow. So I set up a cartridge permanently. You can insert a cartridge and then set the current card as default. That only works with cartridge images from the internal SD card, because USB is not mounted on startup, but it's only mounted when you access it from these menus here. So you can't set up a card that this starts up from a USB thumb drive. I put a version of the Final Cartridge III on my SD card, and that's the Final Cartridge 101% version 2. That's the one I'm running at the moment. And that has several advantages, at least running in an emulator over the regular Final Cartridge images. Yeah, this starts up in the basic mode without holding down any keys, because holding down keys on a USB keyboard at startup doesn't quite work well. As I said, USB is handled a bit strangely because this is a bare metal emulator, so yeah, on startup, the USB keyboard is not parsed quickly enough for getting these key presses on startup. But yeah, this is the version I use. I'm going to link to that in the video description in case you want to do your own. I decided on using the Final Cartridge because that's the one I had when I originally had my C64, and I'm used to the keyboard shortcuts and things like that. It's a pretty quick fast loader that works flawlessly, just like the original cartridge would work. Yeah, that's pretty nice. And you can also, of course, set up ROMs. So you can have, for example, a Jiffy DOS ROM or something like. There are many, many ROMs for the C64 and for the other machines that you can set up to start this up with. And then you just do a save settings. And if you have the file for the ROM on the SD card, it should start up with that ROM, which is pretty cool. You can also just deactivate true emulation, and there's a warp mode here for the auto start mode that loads things a bit quicker than normally, but I found using a regular fast loader to be pretty cool, actually. So I'm doing that. I'm just using Final Cartridge. Just can demonstrate that maybe. Let's see. Let's load something up. And it's a bit... Here's one of the lesser known games. So this is now running the Final Cartridge. So I can press F7 and get the directory. Don't have sound activated. Otherwise you would hear the drive sounds. Let's activate the sound. So I'm loading this. Yeah, and I have a slight cable problem here still. It's humming a bit. But yeah, you can probably hear the drive sounds. Sounds just like a real drive. And it loads much faster than it would with the true drive emulation and without a fast loader. So just wanted to show you that. Now we can play this game here, which is Abyss, which is one of my favorite games from back in the day. Lesser known German game, but very, very good. You should check that out in case you don't know it. I'm going to deactivate sound because in this setup it hums. In my real setup it doesn't hum. That's the little things that I did to improve this and make it a bit easier to work with. And maybe you didn't know some of these. I also found that this actually supports simulating an REU RAM expansion unit. It's in the cartridge menu, of course, because the original REUs are cartridges. So you have the RAM expansion thing here. And you can have an REU up to 16 megabytes, which is pretty handy because you can play some of the more modern games for the C64 like that. And you can save snapshots, which is pretty handy for continuing games or something like that. You want to save a game, you can just save a snapshot, just like you would in the Vice desktop versions. Another thing that got asked quite a bit is whether this works on the newer Raspberry Pis, and unfortunately it doesn't, because they changed some things to an extent where this doesn't work as well on those. So Randy Rossi, who made this in the first place, didn't continue developing for the Raspberry Pi 4 and above. I think we're at 5 now. I'm not the most current. The last Raspberry Pi version I have is a 4. And BMC64 doesn't run on that. But the Raspberry Pi 2 and the 3 and the 3B Plus and the 3A are supported and run rather well. Especially the Raspberry Pi 3s should have enough power for all the features for this. There's also a light version for Raspberry Pi Zeros that supposedly also runs on the Raspberry Pi 1, the first Raspberry Pi, which I also haven't tried, but that's probably pretty funny because you have a dedicated composite out on the initial Raspberry Pis. So maybe I'm going to try that as well at some point. And if you're a tinkerer like me, chances are you have some older Raspberry Pi models laying around anyway. So this is a nice use for those. Okay, let's get into some more modifications that I want to do on camera actually. So in the last video I've shown you how to connect an actual DE9 joystick port on this thing. And that works really well. I don't feel any input lag from that. It's directly hooked up to the GPIO pins and I can use standard joysticks like this old Competition Pro 5000 without any issues. But what if I wanted to use the Competition Pro Star with Autofire and things like that? That is not supported as of yet, because we don't have 5 volts going out of this connector here. And yeah, I read up on this and I'm not 100% sure this is a good idea, but I'm going to try to just hook up 5 volts from the GPIO header to my little joystick port here and see if that makes the Autofire in my joysticks work. So that's the first modification I'm going to try. Yeah, and in case it doesn't work and I wreck my Pi, at least you don't have to try it, taking one for the team, in case it doesn't work. I don't see why it wouldn't work, because basically what these Autofire circuits do is to just pull the fire pin here low, which should work just the same on the Raspberry Pi GPIO pins. Should probably be enough to trigger the fire. Trigger the trigger. And the pins that have 5 volt on here actually are directly coming from the power supply. So if you have a decent power supply, you're not going to run into any issues in regards to not having enough power to actually power the Pi. Because these things usually just take, at the most, a couple hundred milliamps. The original joystick ports didn't have very high power 5-volt lines, of course. So, yeah. We should be good, hopefully, if everything goes according to plan. And I didn't find any forum posts about this, although it seems like a trivial issue, so I'm not quite sure. I also added some translucent rubber feet here on my case, which make it a bit less slippery. Just another little modification I made over the last couple of days. Okay, let's see if we can get Autofire to work here. I'm going to have to open this up again. And then I'm going to have another look at the pinouts. So I'm also going to take my little DE9 socket here out of the equation again. So this is the Wikipedia page for the DE9 joystick. This is the console side joystick port seen from the front. And we have 5 volts power on pin 7 actually. So we should connect pin 7 to one of the pins on our GPIO header, which I'm going to look up after soldering a wire to the pins here. So we have pin 6 and 8 connected, and 7 is the one between them in the lower row with the 4 connectors. So that should be relatively easy. Just going to snip another one of these in half. Female DuPont cable. And solder this onto our pin. So that should be our 5-volt pin, hopefully. And we're going to figure out where to connect it on the GPIO header. And we have 5 volts power on pin 2 and 4, the red circles here. And as I said, allegedly this comes directly from the power supply, so no worries about pulling that too low or anything like that. Should technically be enough juice to run a joystick Autofire circuit from. We'll see. Let's connect this after putting this back in its position. Pin 2, I guess. And I'm pretty sure this is going to work, at least to some extent, so let's see. In case it doesn't work, we can just unplug this. So let's see if it actually works. So far so good. It didn't crash, so the Pi is still running and nothing is complaining. We'll see if my Competition Pro Star from back in the day, this is actually my joystick from way back when, if this actually works. And of course I fired up Turrican. Okay, moment of truth. Yep. We have Autofire just like you would on a real C64 with this joystick connected. So yeah, as I said, I'm not sure if this is going to work for all joysticks, but at least for this one it does. Competition Pro Star, one of my favorite joysticks of all time. And I think most of the joysticks have similar Autofire circuits, so should probably work similar to this. That worked. That's a nice hack. So if you want Autofire on your BMC64, it works just like in a real 64 with connecting one of the 5-volt pins from the GPIO pins to the appropriate pin on the DE9 connectors. As we've seen on the pinout, there are 2 5-volt connectors on the GPIO header, so you can probably even hook up 2 real joystick ports to 5 volts and have them work without even splitting cables or anything like that. Just use the different headers on the GPIO. Yeah, nice. Okay, that's kind of a relief. It seems to work just as I expected. So yeah, close this up again, because the other things I want to do are all in software, basically. This is the hardware I want at this point. With working Autofire. So as I said in the previous video, this emulator supports several different machines that you can all choose from the machine submenu and just start up. Supports the VIC-20, the Commodore 128, which even has the Commodore 64 mode, just as you'd expect. It also supports the Commodore Plus/4, which is basically the same as the C16. It supports the Commodore PAD. So I'm going to install all the files necessary, which are mostly the ROMs for the systems, because this version of Vice doesn't come with the ROMs. Other versions do, as we're going to see. And then we should be able to access and start up all the machines that this can emulate from the comfort of our main menu. For running these other emulators, you need several files, the ROM files. And I have downloaded the Amiga OS version of the Vice emulator. And as it turns out, all the ROM files are included here. So you have the C64 ROM files in the C64 folder here. We have the ones for the C128 in the C128 folder, and so on. And the files you need for the drives are conveniently located in the drives folder. I've chosen the Vice version for the Amiga because it's pretty lightweight, it's a small download, and also it's hosted on Aminet, which is an amazing site to explore anyway. So I'm going to link to that in the video description, and you can, of course, get another version of Vice. Most of them, except for the Linux version, I think, include all the ROMs. So I'm going to look up the files I need on the actual BMC64 website again. We already installed the C64 portion, as you've seen. That works nicely. So let's see, which files do we actually need? And go into the C128 folder. And then we're going to look for all the files we need. Basic high, basic low, kernel 64, so we have the C64 mode. Yeah, we need the DOS 1571, and we need the Chargen basic 64. Oh, we need the Charg 64. That's not on here, but we can use the one from the C64. Okay, let's copy these across to our C128 folder. And we need the Charg 64, which is the ROM. The same ROM as the 64, so we're just going to nip that from our 64 folder here. And we're going to rename it to Charg 64. And then we should have our drive stuff in the drives folder. That's 1571. Yeah, and D1541. That's optional. Because you could, of course, use a 1541 with a Commodore 128, but you didn't have to. So yeah, that's all the files we need, except for the one Z80 BIOS that I don't even know what it's for. We don't need that, it's an optional file. So let's do the same for the other systems that we want. Yeah, and basically the same thing for all the other systems. Okay, we need the +4 Emu. That's the better version, BM +4 Emu, because that does only run on the Raspberry Pi 3, which we have. That's a bit more accurate than the other version. Okay, it gives us a link here where we can download those files. Just going to download these files with the actual download button. Okay, I don't even think we need all of these. So we need the 3+1 ROM. We need the DOS 1541, 1551, P4 Basic, P4 File I/O, that's optional, P4 Kernel, and P4 NTSC. So that's the ones we need. Just going to copy them to the +4 emu folder on my SD card here. And then we want the VIC-20, of course. Okay, I guess that's everything we need. We should now have all these computers in our little box, I guess. Let's try them out in real life. And indeed, I have a VIC-20 running here. It's just a matter of choosing the machines and choosing switch, and then we can switch to the C128, PAL composite, and then it needs a bit of a reboot. And if we did everything right, yeah, we're in Commodore 128 mode now. And we should be able to enter Go 64 and go into Commodore 64 mode. Even from this. Yay! +4 emu, that's the one we installed. Let's see if that boots up. That was a bit more complicated. Yay! And that's the +4 indeed. It has the 64K memory. Let's see, which one did we try? The PAT. Switch. Let's see if the PAT also runs. PAL composite. Yay! It's even 80 columns. Nice. Yeah, that's pretty nifty. We can probably, yeah, we can have different color palettes here according to the system. They are already preset. So we can have a black and white screen or a green screen or an amber screen. Yeah, I now have 1, 2, 3, 4, 5 machines in my little Raspberry Pi box here. That's pretty cool. And it should probably look even better on a real CRT, as we're going to find out shortly. And as I said in the previous video already, there are different Pi heads that you can get for the BMC64 and even different PCBs that you can fit in a real Commodore 64 case, so you have all the joystick ports and the connectivity you need. There's also a feature that allows you to connect real IEC drives to this over the GPIO header. I haven't looked into that and I really don't need that for my setup, but it's really cool that it exists. There's also a variant where you can actually use a real user port, but not all at the same time. So if you have a real C64 keyboard hooked up to the GPIO pins and to joysticks, you won't be able to use any of the other stuff at the same time. But you can use a Kira, which is a USB interface for Commodore 64 keyboards and joystick ports. That allegedly works. You can use the keyboard from the C64 Maxi because the emulation on BMC64 is a lot more accurate than on the Maxi, I guess. There's a lot of possibilities that I'm not going into because I don't really need them for my setup here. Just wanted to show you that you can have all these machines in this little box. And I wanted to try the Autofire thing and show you some of my little adjustments that I made for my particular setup. Okay, I am in the living room in my actual retro gaming corner here. And as you can see, I have the VIC-20 booted up from the BMC. But I'm going to switch to the +4 emu just to get that to show up. Let's see if that works correctly. Yeah, and as you can see, it works just as quickly as the Commodore 64 emulator would. C128. It does look like the real thing, basically. And the pad should also work. Let's see. That probably looks funny. PAL composite. There we are. Ah, I love this. Okay. We can switch different models for the pad as well. 2001. There we are. 8 kilobytes of RAM. Nice. Okay, lovely, lovely, lovely. And as I said, you can just switch this off like you would with a real C64. This should work absolutely fine. It's super compatible. That was another question I got. It's as compatible as the Vice emulator. So really, really compatible. Oh, and actually one thing I forgot to mention, I got some strange lines, wiggly lines, like distortion in the image when I initially set this up. And that was A, because of the very, very crappy cable that I used initially, and B, because of the very, very crappy power supply that I was using. So I switched to one of the original Raspberry Pi power supplies, and it works much better, and I get a clean picture, actually. So, yeah, that's a consideration in case you got some video garbage. Yeah, it really feels like a real C64 on a CRT. And I fiddled with the settings a bit, of course. For the video, you can stretch the picture. I've already shown you in the last video, I think. You can match this up to your actual monitor to look the best it can. You can use different palettes and things, which is pretty nice. Yeah, but it absolutely feels like the real thing, especially played on a CRT here. There's no perceivable lag. I have all the Commodore machines that I wanted, except for the Amiga maybe. Maybe I'm going to put an Amiga emulator on a separate SD card. That is, unfortunately, there's no bare metal Amiga emulator that I know of. But Amiberry, for example, it comes pretty close. It's really cool. There's many Amiga emulators that you can run on a Raspberry Pi, not exactly bare metal, but they are plenty fast enough to have some fun. And you can also hook them up to CRTs with the composite out on the Raspberry Pi if you configure it correctly. Yeah, just wanted to show you that this works absolutely fine in my little setup in the living room here. Back to the lab. Yeah, that's it for today. I hope you enjoyed this. Maybe it inspires you to do the same things I did to your BMC64 setup. Thanks for your time. Special thanks, as always, to everybody who supports me on Patreon or on Ko-fi or on the YouTube channel memberships page or elsewhere. The links to that are in the video description and on my website. And without you, these videos would not be possible. So thank you from the bottom of my heart. That's it for today. I'm Jan Beta. Thanks for watching. See you next time. Bye.